another lesson of Logos and Letters. My name is Liam, and we're going to continue on with our look at parts and how they connect up and all those wonderful things about quantities. Okay, so let us continue. Etideta men ek thesine konton pros alela ton en hautois morion synesteke. So thesin could be familiar to some listening. It's the same word as thesis, means position. From having position, those things having position. Eti deta men ek thesin ekonton prosalela ton en hautois morion synesteke. So for, again, still, or further, those things having position in relation to one another, their parts can meet up as well. All right, their parts can join somewhere as well. So ta de u ex ekonton thesin, those things that do not have position, hoyon tamen tes krames moria thesin ekai. So lines have position. Lines have position in relation to one another. Hekaston ga rauton kai tai puu. For each of them lies somewhere. Kai ekoisan. Ekoisan is that phrase that we looked at recently, and it means one may have or it may be so. You know, it's a really like hypothetical expression. It may happen to be, right? So dielavain, to divide, kai apodunai, to attach. Apodidomi, which is like the base version of it, has so many meanings. So many meanings. But one of the meanings is to attach. Apodunai. So to divide and to attach. Hopu, somewhere, where each of them lie in a surface. Kai pros poyon morion ton loipon synaptai. And where the remaining parts may meet up. So in a clean English translation, he's saying that for all the parts of a shape, have lines, and one may decide where lines join and where they can be divided, and one may understand the relationship between each line and judging by where they lie and how they attach and are divided. Okay, so he's getting really geometrical with his expressions here, and this is useful because he's again reinforcing the physicality of continuous quantities. They're an underlying feature of our existence, and it's clear in this table where the lines lie and how they relate to one another, even in the finer details of the leg and this, or the stump. Even this chair, okay, has clear lines in relation to one another, the photo frames and all these things. And he's really digging into this because of this keyword. This is the keyword of why he's digging into it. Position. Now, position's a key idea when we think about these things. Position, like position ekai, having a position in relation to one another, prosalela, is key because it represents the persistent quality of some continuous quantities. Now, notice this. I write about this in detail and with some level of sophistication in the book, but I'll keep it simple here. Think about how he said that time is a continuous quantity and it has position in relation to one another. Now, we talked about ton paralelu thota and ton melonta, the past and the present connecting at the past and the future connecting at the present, right? But if you extend that just a step further, that line of reasoning, you realize that all of time is connected in a series of moments, like an unbreakable chain, because it's sort of implicit in the name, continuous. Okay, but coming back to the idea, we realize that time isn't a separate stack of moments like books in a bookshelf. You know how you can go and pick out one book in a massive bookshelf, even if the books are all formatted the same and they look really nice, but they're still multi-volume, and you can pick out one volume and the rest will stay there. Time's a bit different. Time is like a series of links in a chain, or links in a chain is probably the best way to express it. And they're all connected. So even though the past is gone, like we can't interact with it anymore, it's like fixed and locked beyond our reach. And same with the future in a way. We can alter what happens in the future, of course, but we can't decide definitively what will happen in the future. Even though that's the case for the past and the present, for the past and the future, it's still related. So every event that happened in the Bible, every event that happened in the Anabasis, I think I've got a painting here somewhere, the Anabasis. Yeah. During the 10,000, the march, is still connected to the present. And it will still be connected to the events in the future. It's connected because the parts aren't separated. They meet at a point. And they meet at the point called the present. So if you were to have a different view of time, if you were to view time from a bird's eye view or just outside of time itself, you would see this unbroken, almost like a surface stretching across, where all time is all events in time are fixed there, all right, ever present, but depending on where you lie in time will alter what you see and can interact with. So these events aren't truly gone, for if you were outside of time, they would still be present, okay? They would still be accessible. Now, if time was separated and broken up into things like books on a bookshelf, it would be a different case. It wouldn't really be so. You would have as many moments of time as there have ever been. That's how many different, this is really hard to put into words, but as many different moments in time as you'd have, that's how many different things you would have to look at, how many different separate silos of time that you would have. But because time is one continuous stretch and it's always connecting at some point, it's not the case. It would be one clean chain, one unbroken chain, accessible, viewable, ordered, intelligible, navigable, sequenced, and flowing from almost like a left to right sentence. And it makes sense that something eternal, something outside of time, atemporal, would be able to view, access, and interact with all of time at all moments. But it wouldn't make sense how that would work if time was separated. So I'll leave that abstract point there. With just the sole takeaway, all you need to take away from that is that time joins up, time's continuous, time does have conceptual positions, and from that we know that something that's eternal can access all of time and see all of time at all times. So that's the implication here. So we'll leave that there, and we'll just reinforce this one point: parts meeting up, all right, in a common spot. And also this, where the things lie, where it lies, has a relation to one another. So not all parts really have a relation to one another, okay? If you looked at 10, the number 10, and you saw 5 and 5, of course that in our minds has a relationship when our reason can add it together, but it doesn't have a necessary relationship. You can't just say the two parts in 10, 5 and 5 have a necessary, these two parts are all that adds up to 10. Because you have to do the adding first. Okay, that's a step that reason takes. 2 and 8, again, you have to use your reason to add that up to 10. However, the past, the present, and the future are like necessarily related. They interact with one another regardless. It happened again. And regardless if you think about it or not. Okay? The past, the present, and the future constantly interacting with one another, regardless if there's an intelligible mind to recognize it or not. Okay? And if we go back to 5 and 5, like I was expressing, right, we have to plus 5 and 5 together. There's this step here that requires reason and intelligibility for 10. Now 10 will always have the parts of 5 and 5, okay? Always have those two parts, 5 and 5. But it takes reason to connect the two to make the 10. Hope that makes sense. Because also you could connect to an 8. You know what I mean? And it takes reason to understand this. It takes reason to know it. It takes a mind to do the process to get the 10. But this does not take a mind to do the process. So there are necessary things that interact in this way, and there are contingent. It's contingent that a mind will add up 5 and 5 and 2 and 8. And all other possible cases like 10. But for continuous quantities, it doesn't seem that it's contingent that they are so. So if you just looked at a natural feature, it's not contingent that any of this arrangement, these natural features, they don't need an intelligent mind to be considering them for them to be so. In another way of explaining that, they don't need to be perceived or reasoned about to exist. Okay? Whereas some things do. This man, looking at them, needs to add up 1 horse and 1 horse to say to himself, there are 2 horses, or there are 3 horses. You get what I mean? Or another example, he might look at the insignia on their jackets and go, okay, he's got a star, he's a colonel, he's got a clover or a leaf or something, he's a major, right? And he has to look, he has to reason, he has to think, and then the understanding comes about. Whereas some things don't need any understanding to just be, to just exist. All right? Some things they just exist apart from any intelligent mind thinking about them or reasoning about them. And some things do require that. So from this point here, we're also learning about how some things are understood, how some things are learnt, how some things require an intelligent mind to reason about it, and how some things don't. All right, so it's getting us started on a lot of different interesting lines of thought, and it's also explaining to us lessons about time and cause and effect in a way. So even though this particular area that we looked at just then is on the surface quite simple and straightforward, the things that we're learning have implications and lines of thought and reasoning which extends far beyond it, far beyond what we're talking about. Even this thing that we just looked at here in this particular lesson, same thing. In short, what I want to finish this lesson on is to say that chapter 6 is a chapter which can seem simple on the surface, but if we stop and pause and follow the line of reasoning that starts out throughout this chapter, you can arrive and you can use it to arrive at really profound, really large conclusions, implications, understandings, become more clear-eyed about how things work and how to conceptualize and classify different things. So if that makes sense, or if you can see how that's the case, then that is awesome. And I'm trying my best here to do this on purpose, because if I only taught exactly what the word said and I didn't follow any of the reasoning, this chapter might seem just like any old math lesson. And I don't want it to seem like that. Okay, like if you see a periscope pointing out of the water and someone says to you, oh look, there's a periscope, that's awesome, but it's even better if the person says, hey look, there's a periscope, there must be a submarine beneath it, beneath the surface. You get what I'm saying? I'm trying to point out what's beneath the surface, because what's beneath the surface is far more interesting than what's exposed above the surface, what's visible to the eye, what's literally superficial. Okay, so I'll end it there. Thank you for your time, and as always, si semper fortis in opere tuo. I'll see you next time.